Welcome back. We're going to be talking about the law of sines today. The law of sines is a continuation of what we've been talking about with triangles, and so we're going to have to keep in mind kind of what sine actually means and kind of these trig ratios that we've been working with all along. But we're going to move into something more abstract, but it's going to allow us to solve for some of the things. So here we go. The law of sines is actually pretty simple, okay? The law of sines simply says this, and I'll use blue for this. The law of sines simply tells us that the sine of A over side A is equal to the sine of B over side B, which is equal to the sine of C over C. Or it allows us to say that A over sine A is equal to B over sine B is equal to C over sine C. All of that, of course, having to do with these values here in the triangle that are given to us. We're going to be using ratios and proportions to help us solve for some of these things. Our first case is this: two angles and one side. So we've been given two angles and a side, and I'll fill that in. And we want to find the length of side C. In doing this, what we're going to do is we're going to set up a ratio, okay? And so we know that the sine of A over A is equal to the sine of C over C is equal to the sine of B over B. This is the law of sines. I just went out of order. It doesn't particularly matter. But what that means is we don't have all the information that we need, because in order to find side C, we are going to need sine of C, which we don't have because we don't have C. So we need to find C. We know that 180 is equal to A plus C plus B is equal to, we have A, which is 30, plus C plus B, which is 70. 100 plus C is equal to 180. So C must be equal to 80 degrees. So we have C is equal to that 80 degrees. Now, what we need to do is we need to set up the ratio. And so the sine of A, which is 30, over A, which is 8, is equal to the sine of C over C. Okay, so this is sine of A over A is equal to sine of C over C. We fill in our values. So when we do this actual calculation, what we end up getting is we cross multiply. So what I am going to do is, in blue here, I'm going to solve for C. Okay? In order to do this, I am going to need to kind of cross multiply. So 8 sine 80 is equal to C sine 30. Do you see where I got that? So it's this butterfly effect, it has been called, or many other things, to solve for ratios. So I have 80 times 8, or sine of 80 times 8 is equal to C times sine of 30. And I'm simply dividing now. Cross multiply and divide. And what I end up with is a series of decimals. So I have 8.0, that's what they gave us, times 0.9848, and make sure that you have your calculator in degree mode. And we have that over 0.5. When I do that calculation, I end up with 16 centimeters for C. Key piece here, you must cross multiply. Okay? Let's move down to the next example. They want us to solve this triangle. And when we solve a triangle, what that means for us is this. We are finding everything that's not there. Okay, so I'm going to fill in what we do have. So C is 82 degrees, and A is going to be 5.6 centimeters. B is 34 degrees, and that's all we have. So we use this, and we use this. So we're not going to need to find three things. I'm going to remember my law of sines here. Sine A over A is equal to sine B over B is equal to sine C over C. Okay, let's fill in what we know. We don't know A, but we could find A. To find A, 82 plus 34 plus the measure of angle A is equal to 180. Okay, so when we add all that up, we actually end up getting 180 minus this sum, 82 plus 34, and that gives us 64 degrees. So this A is going to be 64 degrees. That's actually pretty good for us, because I think that's the calculation that we know how to do. Now we're going to use the law of sines. So let's fill this in. I'll use this maroonish pinky color. Sine 64 over, we actually have A, which is 5.6, is equal to the sine of B, which is the sine of 34, over B, which we don't know, is equal to the sine of 82 over C. Now, this is our key right here, because we have this one. This is what we're going to use for all of the calculations here, okay? And so my first one I'm going to do is I'm going to cross multiply these to find B. Okay, so B times sine of 64 is equal to 5.6 times sine 34. Okay, so that's what we've got right now. When we divide by sine of 64, that actually equals B is equal to 5.6 sine 34 over sine of 64, which gives us 5.6. And these are all decimals. Remember, you need to have your calculator in degree mode because we're dealing with degrees here. So that's 5.6 times 0.5592. Whoops. 2 over the sine of 64, which is 0.8988. When I do this calculation, I get that B is 3.5 centimeters. Let's do the next one. The next one is going to be set up like this. Sine of 64 over 5.6 is equal to sine of 82 over C. Do this little trick here called cross multiplication, so I get 5.6 sine 82 is equal to C times sine of 64 divided by sine of 64 divided by sine of 64. I do all this calculation, all told, remember, degree mode, because we're in degrees here. I'm going to solve for C. So that's 5.6 times. What I've got is 0.9903 divided by, and I kept my sine of 64 for my last problem, 8988. And when I do my calculation, I get that it's equal to 6.2 centimeters. Okay? It's all based on knowing the one ratio. If we know the one ratio, we can find the other two, and we can solve for the rest of our triangle. All right, guys? So try this one, see what you think. Be ready to write me a summary. We'll see you next time.